Find gradient of r to the power n, where r is the position vector. If r is the position vector, then in Cartesian coordinate, r vector can be represented by I cap x plus j cap y plus k cap z, and the magnitude of r is x square plus y square plus z square square root. And gradient of r to the power n means here r is the scalar function, this function, x square plus y square plus z square square root, and we have to find out the gradient of r to the power n. I have told you that gradient of a scalar function can be denoted by or represented by a del operator, and del operator is a vector operator which operates on the when operates on the scalar function, this will give you gradient, and gradient is a vector. And here del operator, which when operates on r to the power n, what will happen? We know del operator is I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z of r to the power n. So this can be, since r to the power n is a scalar function, this can be written as I cap partial derivative of r to the power n with respect to x plus j cap partial derivative of r to the power n with respect to y plus k cap partial derivative of r to the power n with respect to z. Suppose this is equation number 1. To find the gradient of r to the power n, we have to first take the partial derivative of r to the power n, means r is equal to x square plus y square plus z square whole to the power half to the power n with respect to x. First we will find out the partial derivative with respect to x, then we will find out the partial derivative of r to the power n with respect to y, then partial derivative of r to the power n with respect to z, then we put the values in equation 1 to find the gradient of r to the power n. So let us first find out the partial derivative of r to the power n with respect to x. Partial derivative of r to the power n means x square plus y square plus z square whole to the power n by 2. When you find out the partial derivative, this will be equal to n by 2 x square plus y square plus z square n by 2 minus 1, and derivative of x square is equal to 2x. So here 2 cancels. So n into x square plus y square plus z square to the power n by 2 minus 1 is equal to n minus 2 divided by 2. So partial derivative of r to the power n with respect to x is equal to this much. Suppose this is equation number 2. Similarly, you can also find out the partial derivative of r to the power n with respect to y. And following this procedure, this will be equal to ny x square plus y square plus z square whole to the power n minus 2 divided by 2. Similarly, partial derivative of r to the power n with respect to z is equal to nz x square plus y square plus z square whole to the power n minus 2 divided by 2, following this procedure. And suppose this is equation number 4. Now you substitute the values what you have derived from in equation 2, 3 and 4 here, that is in equation 1. If you substitute, then you will get the gradient of r. Then gradient of r will be equal to, you can take common n, so that and also you will take common x square plus y square plus z square whole to the power n minus 2 divided by 2, so that in the bracket you have I cap x plus j cap y plus k cap z, and this is nothing but the position vector, that is r vector, and x square plus y square plus z square, this is nothing but r square. So r square into n minus 2 divided by 2. So here this step will be equal to, you see 2 cancels, so this will be equal to n into r vector, that is position vector, into magnitude of r to the power n minus 2, because 2 cancels. So you can rewrite this like this, because we know r vector is equal to r into r cap, that is magnitude of r into r cap. So in r vector, if you write magnitude of r into r cap, magnitude of r means r to the power 1, and here n minus 2 plus 1. So this will be equal to r to the power n minus 1. So gradient of r to the power n will be equal to n into r to the power n minus 1 into r cap, that is the unit vector. So in this way you can find out the gradient of r to the power n, and you have to remember this formula. In many problems this formula is very useful, and in general if you write the general form of the gradient of any vector, that is any scalar, then in the gradient of any scalar, then scalar function, that will be equal to, you see, first derivative of the scalar function into the unit vector. Okay, you have to remember these two formula. If it is given the scalar function is r to the power n, then gradient of r to the power n is equal to n r n minus 1 into r cap. And if the function r to the power n is given any scalar function phi r, then gradient of phi r will be equal to phi dash r, because you see this is the if r to the power n, this will be the first derivative n r to the power n minus 1. So the first derivative of this scalar function phi r will be equal to phi dash r into r cap, that is the unit vector. And these two formulas are very useful in mathematical physics, and while solving various problems in physics and mathematics, these two formulas are very useful.